Hello everyone, this is Pure Mathematics, Chapter 1, Section 1.10, which is about quadratic modeling. So in the previous videos, we have seen about this quadratic function and the graph of the quadratic function, which is a parabola. Now in this video, we are going to look at some examples where we can apply the quadratic function concept to find in the solutions for real life problems, real world problems like. So there are many situations in the real world where the relationship between the two variables is a quadratic function. That means the relation between x and y, the two variables, is a quadratic function like y equal to ax square plus bx plus c. Then we have these following examples where we come across such quadratic functions and we solve those real world situations. So let us take this example. The height g meters of a ball hit vertically upwards t seconds after it is hit is given by gt equal to 12t minus 3t square. So if you observe here, t is the independent variable, that is in place of x we have t here, and g is the function which depends on t and which is a quadratic square, t square and t. So it has the two terms here, minus 3t square plus 12t, which is clearly a quadratic function. So for this quadratic function, we have to answer these questions. How long does it take for the ball to reach its maximum height? What is the maximum height of the ball? And how long does it take for the ball to hit the ground? So what is this gt here? The height. G is height. That means gt is the height. Height depends on the time t. So t is the independent variable which is taken on x-axis, and the image gt is taken on the y-axis. So to write this parabola, which is a parabola, quadratic equation is always a parabola. So once we are given this parabola equation, the quadratic equation, to find the parabola, first you have to find the vertex and the shape of the parabola. Is it upwards or downwards? So let us compare this given equation. gt equal to minus 3t square plus 12t with the standard quadratic function at square plus bt plus c. In place of x, we have taken t because t is the independent variable here. So t, so at square plus bt plus c, if we compare, a equal to minus 3, t square coefficient, a is minus 3, and t coefficient is b, that is 12, so b is 12, and c constant, there is no constant here given, so c is 0. So a we got minus 3 and b is 12 and c is 0. If we put ABC in the formula for h and k, which is the vertex, h is minus b over 2a, that is equal to minus b is 12 over 2 times a is minus 3. If we simplify, you will get 2. Similarly, k equal to c minus b square over 4a. This is the formula for k. And if we substitute ABC values here, c is 0 minus b square, that is 12 square, or 4 times a, 4 times minus 3, and after simplification we will get 12. So h is 2 and k is 12. This is the vertex, and t square coefficient, which is a is negative, a is minus 3 is negative. So the parabola will be downwards and downwards with the vertex hk, which is 2, 12. So let us look at the graph. So this is the t-axis. Instead of x, we write now t on x-axis here, t-axis here, t is the time. And this is gt, which is the height. gt is given. So gt is the y-axis. On y-axis, we take gt, which is the height, and t is on x-axis, that is t is the time. Now we have seen the parabola vertex is hk. H is 212. So this is the point 212 when x is t is 2 and gt is 12. So this is the vertex, and Since a is negative minus 3, the parabola is downwards. Now, what are the questions we have? If you look at the first question there, how long does it take for the ball to reach its maximum height? That is the first question. So, what is the maximum height? How long does it take? So, here, if you observe, this is the time t on x-axis. So, t initially here is 0 because when t equal to 0, g is also 0. The height is also 0 when time t is 0. And if you observe, as t is going from 0 to 2, the time is going from 0 to 2. The height is increasing up to 12. So the maximum height it takes the ball when t equal to 2. So after how many minutes the ball reaches its maximum height? When t equal to 2. So how we are writing these points here? The parabola is downwards because a is negative. The vertex is at 212. I made this point, this is the vertex. And the axis of symmetry. What is the axis of symmetry? We have the formula for that. X is equal to h. Here h is 2. So x is equal to, here in place of x we take t because an x-axis the independent variable is t. So t equal to 2 is the axis of symmetry. T equal to 2 is the axis of symmetry. So if you observe this graph, the height is increasing from when x is t is, the time is going from 0 to 2, and the ball reaches its maximum height, that is 12. Maximum height is 12 when time is 2 seconds. Therefore, gt equal to 12 when t equal to 2, which tells that the ball reaches maximum height after 2 seconds. The maximum height is 12, and when it reaches after 2 seconds when t is equal to 2. That is the answer for the first option A. And the second option B is, what is the maximum height of the ball? Here clearly we can see the parabola has maximum, and the maximum value is 12. When t equal to 2, the maximum value, which is the height, maximum height is 12. So the maximum height of the ball is 12 meters. And then the third question, third option here is, when the ball reaches the ground. That means when the gt, the height will become 0. Here if you observe, gt equal to 0, we have to substitute. The height is nothing but gt. So the equation given, we are given gt is minus 3t square plus 12t, and gt, the height is 0, means gt is 0, that is minus 3t square plus 12t equal to 0. And if we solve after taking minus 3t from both terms as a factor, minus 3t times t minus 4. From minus 3t square plus 12t, if we take minus 3t as factor from both, we'll get minus 3t times t minus 4 equal to 0, which implies t equal to 0 and t minus 4 equal to 0. That is t equal to 4. Therefore, the ball reaches the ground when t equal to 0 and when t equal to 4 again. So initially the ball is on the ground only, that is at time t equal to 0. This t equal to 0 is that one. And again when t equal to 4, it reaches the ground again. In the middle, when t equal to 2 seconds here, when t is 2 seconds, the ball reaches its maximum height, which is 12. And again when t equal to 4, after 4 seconds, the ball reaches the ground, because gt equal to 0, gt nothing but the height. Height is 0, means the ball is reaching the ground when t equal to 4 seconds again. So this is how you write the solution or the answers for the given questions based on this parabola, the shape of the parabola and the vertex. Let us go to another example here. A shirt manufacturer finds that the cost in how many reals f of making X shirts per day is given by Fx is equal to x square minus 40x plus 500. So this is the cost. Cost is Fx. And what is X is here? X is the number of shirts. So relation is between X and Fx. X is the number of shirts and Fx is the cost. Cost is given as a quadratic function here. X square minus 40x plus 500. So from this quadratic function what we observe? It is a parabola and it is upwards because x square coefficient is 1, a equal to 1 here, 1 is greater than 0, therefore this parabola is upwards, and this is the relation between the number of shirts x and the cost associated with that, that is fx, given by this quadratic function. So let us look at the other questions we have here. How many shirts should be made per day to minimize the cost of the production? That means when the function fx, the quadratic function fx is minimum, because to minimize the cost means for what x value this fx is minimum. That is the first question. Second, what is the minimum cost per day? So what is that minimum value of fx? Okay, this is just associated with the first part. How many shirts should be made means for what is the x value to make fx minimum. Okay, and the second is what is the minimum cost? That means the fx value, the fx value, the minimum fx value, the cost. And the third one is what is the cost if no shirts are made? That means when x is 0, x is the number of shirts. So if no shirts is made means when x is 0, what is the cost? That is fx value when x is 0. So let us try to answer all these three questions. First, write the vertex. To find the vertex, write the equation fx, given equation, which is the quadratic function. Fx is x square minus 40x plus 500 is equal to ax square plus bx plus c. And if we compare a equal to 1 here, x square quotient, and b, which is x quotient, b is minus 40, x quotient is b, which is minus 40, and c, the constant, c equal to 500. So once you get a, b, c, you can find the vertex hk. H is the formula, h is equal to minus b over 2a, that is equal to minus, b is minus 40 over 2 times a is 1, that gives, if you simplify, 20. So h is 20, and k equal to c minus b square over 4a, and c value, c is 500 minus b square, so b is here minus 40 whole square over 4 times a is 1, and if you simplify this you will get 100. So you got h is 20 and k is 100. Once you get h and k, that means you have the vertex. Vertex is hk, that is 20, 100, and this parabola is upwards because this a is 1, which is greater than 0, positive. So let us write the graph. So this is the graph of the parabola. The parabola is upwards and the vertex is at 20, 100, and x is on x-axis, which is the number of shirts, and fx is the cost, that is on y-axis. Y-axis is the image fx. Fx is on y-axis, which is the cost. Now the parabola is upwards, as we have seen, since a is greater than 0, a is 1, which is greater than 0. Now regarding the first question, the number of shirts should be made to minimize the cost. Here the cost is minimum at this x value. X is 20, when x is 20, if you see, when x is 20, what is the minimum value of fx? Minimum value is 100. For all other x values, fx is increasing to infinity on either side. Fx has minimum value when x is equal to 20. The minimum value of fx is 100. So this is asked here. The minimum the number of shirts should be made to minimize the cost. How many shirts should be made? That means X. What is the X value to minimize FX? FX is the cost of the shirts. So to minimize this cost, what is the X value? So what is the X here? 20. So how many number of shirts should be made to minimize the cost? 20 shirts. So X is equal to 20. So the number of shirts should be made to minimize the cost is X is equal to 20. That is 20 shirts. The second question is, what is the minimum cost? So when we are making 20 shirts, we are getting minimum. And what is that minimum cost? FX. FX is here 100. FX is 100. So the minimum cost is at X is 20. And what is that minimum cost is 100. 100 is the minimum cost that occurs when X is 20. So here minimum cost is asked. So minimum cost is 100. And the last one, the third one, if no shirt is made, what is the cost? No shirt is made means X is 0. When X is 0, that means if we put X is 0 here, this is the point, the cost when no shirt is made. By putting X is equal to 0 in this equation, Fx is the cost, which is given by quadratic function x square minus 40x plus 500. In that, if we put x is 0, this x square will be 0, 40x will be 0, you will be left with only 500. So when no shirt is made, how much cost? F of 0, when x is 0, the cost will be 500. So 500 many reals will be the cost if no shirt is made because of the maintenance of the factory. You may wonder, if no shirt is made, why we are having this cost 500 many reals? Because of the maintenance of the factory, it may be the cost 500 according to this equation, according to this quadratic function, where fx the cost is x square minus 40x plus 500. So this is how you find the parabola, finding the vertex and the shape. Thereafter you can answer the real world situations where the relation between the two variables is a quadratic equation or quadratic function. Now these are the problems in the exercise. Here the height is g. Height of the ball hit vertically upwards t seconds after it is hit is given by gt. So the height is given by this equation. Gt is 80 minus 2t square, which is a quadratic function again, and t is the independent variable. In place of x we have t here. So we take t on x-axis, which is the time, and gt, that is the height, on y-axis. And you can write the parabola, the vertex, and the vertex will the parabola will be downwards because the t square coefficient minus 2, which is negative, so the parabola is downwards. And using the other vertex and other properties of the parabola, you can answer these questions ABC. Similarly, another question here, the television manufacturer finds that the cost in many reals is fx of making x televisions. Here the relation is between x and fx. X is the number of televisions made and fx is the cost of the cost for making x televisions. So using this relation, which is a quadratic function, you can again answer these questions A, B, C. So this is the end of this video.